Welcome back. Let's talk about how to find the number of geometrical isomers in a molecule. As you know, molecules can be either unsymmetrical or they can be symmetrical depending upon the connectivity or the structure of that molecule. If the molecule happens to be unsymmetrical, then the number of geometrical isomers is given by this formula. That is, number of geometrical isomers will be equal to 2 raised power n, where n is the number of stereocenters in that molecule. However, if the molecule happens to be symmetrical, then the number of geometrical isomers is given by 2 raised power n minus 1 plus 2 raised power p minus 1, where p will be equal to n by 2 if n is even, or p will be equal to n plus 1 by 2 if n is odd, where n, as usual, is the number of stereocenters in that molecule. Now let's try to illustrate this with certain examples. We have this molecule. In this molecule, as you see, there are 3 double bonds. So you expect there can be 3 stereocenters possible in that molecule. But actually there are just 2 stereocenters designated by star. The third one is not a stereocenter because one of the restricted carbon is attached to 2 similar groups, that's hydrogens. So clearly there are just 2 stereocenters in that molecule. Moreover, as the molecule is unsymmetrical, clearly the number of geometrical isomers will be equal to 2 raised power n, and as there are 2 stereocenters, that will be equal to 2 raised power 2, and that will be equal to 4. So the number of geometrical isomers in that particular molecule will be just 4. In the next example, as you see, there are 2 double bonds. So you expect there can be 2 stereocenters in that molecule, and it is because each restricted carbon do contain 2 different groups attached, and moreover the molecule is symmetrical. As you can see that one half is same as that of the other half. So the number of geometrical isomers will be equal to 2 raised power n minus 1 plus 2 raised power p minus 1, and that's equal to 2 raised power 2 minus 1 plus 2 raised power 1 minus 1, because the value of p will be equal to 1 since it's equal to n by 2, as there are even number of stereocenters. So that boils down to 3. So the number of geometrical isomers in this particular molecule is 3. Similarly, talking about the other example, in this particular case, there are 4 stereocenters expected, and it is nevertheless true as each restricted carbon in the double bond is attached to 2 different groups, so they become the stereocenters. Moreover, in the case of rings, the 2 restricted carbons do contain 2 different groups and are also sp3 hybridized. Clearly, both the rings will be stereocenters. So in total, there are 4 stereocenters in that particular molecule. As the molecule is unsymmetrical, so the number of geometrical isomers will be equal to 2 raised power n, that equals to 2 raised power 4, and that gives the number of geometrical isomers equal to 16. In the next case, we have 2 rings as well as 2 double bonds. So the 2 double bonds are nevertheless stereocenters. One of the cyclohexane ring is a stereocenter because it contains 2 restricted carbons with 2 different groups attached, and both are sp3 hybridized. The other ring do contain 1 restricted carbon, 2 different groups, but not the other, so this does not become a stereocenter. So in total we have 3 stereocenters possible in that molecule, and as the molecule is unsymmetrical, so the number of geometrical isomers will be equal to 2 raised power n, and that boils down to 2 raised power 3, and that gives you the number of geometrical isomers equal to 8. Now I'm asking you to find out the number of geometrical isomers in the following molecules. The molecule A we have, and the molecule B. Once you finish up, please write the answers in comments. Thank you.